So now we're going to look at equations for sinusoidal models and pull information out from them. So in this case, we're talking about a water wheel. So a water wheel is a wheel attached to some sort of mill. It's got paddles that come out, and there's a river flowing, and the force of the river makes the water wheel spin, which turns some kind of mill or grinder inside the building attached to it. But in this case, our equation is y equals -4 cos of 6x plus 4.8. I did change that in the question. So plus 4.8. Similar to when I was graphing them, I'm going to pick the information out and that'll be able to tell me what's happening. So that means the axis of curve, or the middle, is 4.8 meters, and the amplitude I can see is 4 meters. Because this river is probably a little bit above ground, so there's 0.8 of a meter in between the top of the water and the very bottom of the ground. But the important thing is that the axle is at 4.8 meters. So the axle that runs into, that turns, is 4.8 meters above the ground. The radius of the wheel is 4 meters because it's 4 meters above that middle point, or the diameter is 8 meters. Now I want to get the speed of the wheel, because the physical information about the wheel, I've described the circle. It's a circle that has radius 4 or diameter 8. In the middle is 4.8 high. Now in this case, k is 6. So that means I'd get 6 shapes in 360. So now if I do 360 divided by 6, that gives me 60. So that means one revolution is 60 seconds. So it takes a minute for this wheel to turn all the way around. That's all the physical information I can give about the wheel, is the size of it and how fast it's going. Now when it says what is the height of that paddle after 30 seconds, I'm going to take my equation, -4 times the cos of 6x plus 4.8, and I'm going to put 30 for the x. And in between the 6 and the x is multiplication because they are touching. So I do the brackets first. So 6 times 30 is 180. Now I'm going to ask my calculator what the cos of 180 degrees is. And you should get -1. So this becomes -4 times -1 plus 4.8. So that gives me 4 plus 4.8, or 8.8 meters. So after 30 seconds, it's 8.8 meters tall. Whatever, if this is the paddle that we're talking about, it would be 8.8 meters high after 30 seconds. So now a Ferris wheel has diameter 15. So right away I know that the radius is 7.5 and completes one revolution every 45 seconds. So 1 in 45. So that's my new period, because period means how long it takes to complete a revolution. The loading platform is 0.75 meters tall or above the ground, because when you're talking about a Ferris wheel, the carriage does not sit on the ground when you get into it. And assume that the rider starts at the lowest point to find an equation that models the height of the rider in meters after so many seconds on the ride. So just to kind of give you an idea of what's happening, we get on the ride at 0.75. The diameter is 15, so my highest point is going to be 15.75. And then the radius is 7.5, so, or the middle of that is going to be 8.25. Just going to double check my math. What you want to do is take your highest and your lowest, add them up, and divide by 2. So 15.75 is my highest, plus 0.75 is my lowest. Divide that by 2, and it absolutely does give me 8.25. So again, I just averaged my highest plus my lowest divided by 2. And I knew this had to be my highest because 15 meters is the diameter of my Ferris wheel, and I'm not starting right at the ground, I'm starting at 0.75. So assume that the rider starts at the lowest point of the ride, and it's going to take 45 seconds for them to go up to the top of the ride and then come back down. This is not going around in a circle, we're modeling their height, and that takes 45 seconds. So if I'm finding an equation, I'm actually going to do a cos equation because this is an upside down cos. You 100% could give a sine equation. It's up to you and start it there. But this is an upside down cos where the amplitude is 7.5 because that's the radius, half of the wheel, or the distance in between the axis of curve and the lowest and highest point. Cos, I'm going to click K in a second, x plus 8.25 because that's where the axis of the curve is. So now the only thing I'm missing is K, is how many shapes I would get in 360. Well, K is always the old period divided by the new period. The old period, no exception, is 360. And if I do 360 divided by 45, that should give me 8. So 8 is what goes in front of my x. So an equation that models this is negative 7.5 cos of 8x plus 8.25. There are more right answers than that. You could have started it there and say, okay, this is 22.5 because it's halfway to the end. So I could keep it a positive cos graph and do 8x minus 22.5 because remember, if the graph starts forward, then it's actually a negative. You could do a sine where it starts there, and if that's 22.5, that's going to be 11.25. So you by keep finding your halfways, but any of these work. You just need one equation that works. So this gives a table for the average daily temperature in Kapuskasing. They took each day's temperature for the month and averaged it and came up with an average for that month. So January is going to be 0, 1, 2, 3, 4, 5. And I knew to enter in those numbers because in the question they said, let January equal 0. So the first thing I'm going to do is create a scatter plot of the data. So I have some graph paper, and I'm not going to need any negatives on my t-axis because t, or our time, is months, and we're not going to go back in time. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my X, or my months. And in this case, I'm going to look at my numbers. My lowest is negative 18.6. My highest is 17, so I'm going to use that to come up with a scale. So I might go 5, 10, 15, 20, negative 5, negative 10, negative 15, negative 20. So these are my temperatures, and these are my months. You could call them X and Y. There's nothing wrong with that. And now I'm going to plot all the values as best I can. I'm not going to get exact because I don't have a scale that lets me do negative 18.6 exactly, but I'm going to do them as best I can. So negative 18.6, negative 16.3 are my first two. So 0 and negative 18.6, negative 16.3. My next two are negative 9.1 and 0.4. So negative 9.1 and 0.4. Oops. My next two are 8.5 and 13.8. So 8.5, 13.8, 17 and 15.4. So 17, 15.4, 10.3 and 4.4, 10.3, 4.4, and negative 4.3 and negative 14.8. So negative 4.3 and negative 14.8. So there's my scatter plot, and I just graphed all the numbers 0, negative 18.6, 1, and negative 16.3. And then a curve of best fit means to join those dots up as best you can. Okay, and if you really wanted to keep it going, this month was 11 or December, so the next one will be back to January again, so it's going to kind of follow because this was December and that was January. And that does kind of look cos or sine-ish. It has the idea of a wave. So create a scatter plot of the data, draw the curve of best fit. The first thing I'm going to do is look for my axis of curve, or my D, my number at the end, because that is the middle of the graph. So if I look at my graph, my axis of curve is going to be somewhere in the middle. It looks like it might be around 0 in this case, but it might not be. The axis of curve is always in the middle of your highest and your lowest point. So I'm going to find the average of negative 18.6 and 17.0 by adding them up and dividing by 2. So if I add those up, I get negative 1.6, and then if I divide them by 2, I get negative 0.8. So my axis of curve is actually just below y equal to 0. So my number at the end is going to be minus 0.8. Now the next number I'm going to look for is my amplitude. Couple ways to find the amplitude. You can just figure out the distance from this axis of curve to the highest or to the lowest point. In this case, it should be 17.8, and I did that going, okay, if I start at negative 0.8 and I have to go all the way up to 17, I'm going to get 17.8. But another way to do that is to look at the difference between the two, the highest and the lowest, and divide it by 2. So to find the axis of curve, we average them by adding. To find the amplitude, it's half of the difference between the highest and the lowest point. So I'm going to do 17 minus 18.6 divided by 2. So 17 minus minus negative 18.6 gives me 35.6 divided by 2, which also gives me 17.8. So my amplitude is 17.8. And now if I look back at my graph, this is a perfect upside down cos graph. So I'm going to make my amplitude negative to say flip cos upside down. If I didn't do that, I'd have to find a starting point, which isn't a big deal. That would be 6. I could leave it positive and move it, but I like the simplest equation. So if I put a negative on my amplitude, I have an upside down cos, and I'm done. I don't need a movement then. So now the only thing I'm missing is my k value. So remember, my k value is how many graphs I would get in 360, or it's my old period divided by my new period. Old period without exception is 360. New period is how long it takes to complete one cycle for the information. Well, you can look at the graph to see it, or you can say, well, wait a minute, these are months. 1 year is a cycle, so it takes 12 months to complete one cycle. So I'm going to do 360 divided by 12, which should give me 30. So then the equation is y equals negative 17.8 cos of 30x minus 0.8. I found my axis of curve by averaging my highest and lowest points. Add them up and divide by 2. I found my amplitude by looking at half the difference between the highest and the lowest. So I went 17, subtract negative 18.6 divided by 2 to get 17.8. I could leave my amplitude positive, but in this case, if I just make my amplitude negative, I don't have to move the graph left or right. It is a perfect flip cos graph. Then to get my k, I do 360 divided by how long does it take to complete one cycle. If we look at our graph, it would complete one cycle or get back to where it started at 12. 11 was our last piece of data, but then it would start repeating itself after that. Or you can just logically say one cycle for a year is 12 months. 360 divided by 12 is 30. There are lots of different correct answers for this. You could use a sine graph, and you could use a different coast graph depending on your starting. But now it wants, what will the average monthly temperature be for the 40th month? I'm going to take my equation and put 40 in for x. And again, because the 30 and the x are touching, there's a multiplication there. 30 times 40 is 1200. Now I have to ask my calculator what the cos of 1200 is. In the last example, when we did this, the cos of 180 was a nice number. It was 1. Now I have to get it to see what it would be for 1200. So I'm going to say the cos of 1200 is negative 0.5. So I have negative 17.8 times negative 0.5 minus 0.8, because my calculator told me when I typed in, and depending on your calculator, some calculators you go cos of 1200, other calculators you do 1200 cos, but your calculator should give you negative 0.5. So 17.8 times negative 0.5 is 8.9, and it'll be positive 8.9 because a negative times a negative is a positive. Subtract 0.8 gives me 8.1. So for the 40th month, the average temperature should be 8.1 degrees.